Welcome to YQ Academy Collections Framework Java Interview Questions and Answers. 1. Explain copyOnWriteArrayList and when do we use it? copyOnWriteArrayList is a thread-safe variant of ArrayList in Java, which means it can be safely accessed and modified by multiple threads concurrently. It achieves thread safety by making a fresh copy of the underlying array every time a modification operation such as add, set, remove is performed. This approach ensures that the original array remains unchanged and allows concurrent reads to occur without synchronization. copyOnWriteArrayList is commonly used in scenarios where there are frequent read operations and relatively infrequent write operations. It is suitable when the list is small or when the cost of creating a new copy is not a concern compared to the benefits of concurrent read access. 2. Explain about fail-fast iterators in Java. Fail-fast iterators are iterators that throw a concurrent modification exception if the underlying collection is modified while an active iteration is in progress. The term fail-fast refers to the immediate detection of any concurrent modifications, ensuring that the iterator fails quickly and notifies the developer about the potential data inconsistency. The fail-fast behavior is a safety mechanism designed to catch and prevent potential issues that may arise when multiple threads modify a collection concurrently. It helps to maintain the integrity of the data structure and avoid unexpected behavior or data corruption. Key characteristics of fail-fast iterators. 1. Detection of concurrent modifications. Fail-fast iterators keep track of the underlying collection's modification count. During each iteration, they compare the expected modification count with the actual count. If they detect a modification such as adding or removing an element that occurred after the iteration started, they immediately throw a concurrent modification exception. 2. Immediate failure. When a concurrent modification is detected, the fail-fast iterator throws the concurrent modification exception immediately. This behavior ensures that the developer is promptly notified about the modification and prevents any further iteration using the same iterator. 3. Non-deterministic exception throwing. The exact timing and location of the concurrent modification exception being thrown by a fail-fast iterator are non-deterministic. It may occur at any point during the iteration when a modification is detected. 3. Explain about fail-safe iterators in Java. Fail-safe iterators are iterators that operate on a copy of the underlying collection instead of the original collection. Unlike fail-fast iterators, fail-safe iterators do not throw a concurrent modification exception if the collection is modified during iteration. Instead, they continue to operate on the original collection snapshot taken at the time of iterator creation. Fail-safe iterators are generally less error-prone in concurrent environments compared to fail-fast iterators. They allow for safe iteration over a collection without the risk of concurrent modification exceptions. However, they may not reflect the most up-to-date changes made to the collection during iteration. Some examples of collections that offer fail-safe iterators include concurrent hashmap and copyOnWriteArrayList. Key characteristics of fail-safe iterators. 1. Copy of collection. Fail-safe iterators work on a separate copy of the original collection. When an iterator is created, it takes a snapshot of the collection's elements and operates on that snapshot independently. 2. No concurrent modification exception. Since fail-safe iterators operate on a copy of the collection, They do not throw a concurrent modification exception even if the original collection is modified during iteration. The modifications in the original collection are not visible to the iterator. 3. Consistent iteration. Fail-safe iterators provide a consistent view of the elements as they existed at the time of iterator creation. They do not reflect any modifications made to the collection after the iterator was created. As a result, they are not affected by modifications made by other threads. 4. Explain the concept of CountDownLatch in Java and discuss a scenario where it can be useful. CountDownLatch is a synchronization construct provided by the Java concurrency framework. It allows one or more threads to wait until a set of operations or tasks, represented by a specified count, has been completed by other threads. A CountDownLatch is initialized with a count value, representing the number of events that need to occur before the waiting threads can proceed. The count is decremented by other threads as they complete their operations or tasks. Threads that need to wait for the completion of the events call the await method on the CountDownLatch. This method blocks the calling thread until the count reaches 0, indicating that all the required events have occurred. Other threads perform countdown operations by calling the countdown method on the CountDownLatch. Each invocation decrements the internal count by 1. Once the count reaches 0, all waiting threads are unblocked and can proceed. Use cases. 1. Parallel computation. You can divide a complex computation into smaller tasks that can be executed concurrently by multiple threads. Each thread can decrement the count when it completes its task, and the main thread can wait using await until all tasks are finished. 2. Coordinating the startup of multiple services or components in an application. You can create a CountDownLatch with a count equal to the number of services or components and have them all call countdown when they are ready. The main thread can then use await to wait until all the services or components have finished initializing before proceeding. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.